Welcome to my channel. In this video we are going to learn about properties of integers. These properties of integers are very important too in our 7th class, 8th class and 9th, 10th also. Yeah. Positive, negative and 0 are called integers. The integers are denoted by Z or I. In this video we have to learn closure property, commutative property, associative property, distributivity, additive identity, additive inverses, multiplicative identity, multiplicative inverses. First, closure property under addition. Now, we know very well integers positive, negative and 0. In this table, we observe statement 1 conclusion. What is the statement here? 6 and 3. 6 is one of the integer, 3 is one of the integer. This sum is, we get 9. 9 also an integer. So the sum is an integer. Minus 10 and 2. These are two integers. The sum is, we get minus 8. Minus 8 also an integer. So therefore the sum is an integer. Minus 3 and 0. These two are integers. So sum of these two, we get minus 3. So the sum is an integer. Minus 2 and minus 3 are two integers. The sum of these two integers, we get minus 5. The sum is also an integer. And plus 4 plus minus 4, we get 0. 0 also an integer. Therefore the sum of two integers also an integer. Now 7 plus minus 6, we get plus 1. So 7 is an integer, minus 6 an integer. This sum is 1. 1 also an integer. So the sum is an integer. By observation from this table, sum of any two integers always an integer. This property known as closure property under addition. Now integers are satisfied closure property under addition. In general, for any two integers a and b, a plus b also an integer. Next, commutative property under addition. Now statement 1, statement 2 and conclusion. So in statement 1, here observe 5 plus minus 6. 5 is an integer, minus 6 is an integer. This sum is minus 1. Same here, minus 6 plus 5. This sum is also get the same answer, minus 1. Here we observe plus 5 plus minus 6, we get the minus 1, and minus 6 plus 5, we will get a minus 1. Here in statement 1, we have same answer, minus 1, and in statement 2 also same answer. Plus 5 plus minus 6 is equals to minus 6 plus 5. So now conclusion is 5 plus minus 6 is equals to minus 6 plus 5. And one more example, minus 9 plus 2, we get a minus 7, and 2 plus minus 9 is equals same minus 7. Now from statement 1 and 2, from statement 1 and 2, what we conclusion here? Minus 9 plus 2 is equals to 2 plus minus 9. And another example, minus 4 plus 5 is equals to, we get a 1, and 5 plus minus 4, 5 plus minus 4. Here first we add a minus 4 to 5. Here 5 add to minus 4. So we get the same answer is minus 4 plus 5 is equals to 5 plus minus 4. Next, 3 plus 4, we will get a 7, and 4 plus 3, what is the answer? Same, we get a 7. Now what we conclude here? 3 plus 4 is equals to 4 plus 3. By observation from this table, integers are satisfied commutative property under addition. This property known as commutative property under addition. Now in general, for any two integers a and b, a plus b is equals to b plus a. Associative property under addition. Now statement 1, statement 2 and conclusion. So here we take 3 integers. If we add 3 integers, we could not add 3 integers at the same time. Now in this first 2 integers add, and after then we add the 4. Now 2 plus 3 is 5 plus 4. 5 plus 4 is 9. And in statement 2, we take the same 3 integers, 2 plus 3 plus 4. We could not add 3 integers at the same time. First we add the 2 integers, and after then we add the third one. So in this case, in statement 2, we add last 2 integers. Now 2 plus 3 plus 4 is 7. Now 2 plus 7 is equals to 9. From this statement 1 and 2, here in statement 1 we add 3 integers, in statement 2 we add 3 integers, same integers. But in statement 1, first 2 integers added, in statement 2 last 2 integers are added. But wherever we get the same answers. Now we conclude that 2 plus 3 plus 4 is equals to 2 plus 3 plus 4. And one more example, minus 3 plus 6 plus minus 5. Now we add the first 2 integers. Next, sum of first 2 integers we get a plus 3, and third integer is a minus 5. So 3 plus minus 5. Now sum of these 2 integers we get minus 2. In statement 2, we take same integers, minus 3 plus 6 minus 5. We will add last 2 integers, that are 6 plus minus 5. We get the same answer or not? Just we verified here. Now minus 3 is here, and sum of last 2 integers is we get only 1, and minus 3 plus 1 we get the minus 2. So now in statement 1 we get a -2, and in statement 2 we get a same -2. Now by these two statements we conclude that -3 plus 6 plus -5 is equals to -3 plus 6 -5. One more example. We add a -1, -2 plus 6. But here also we could not add three integers at the same time. In this case, now we add first two integers, after then third integer. Now sum of first two integers we will get a -3, and the third integer is a -1. Now sum of these two integers again get a -9. Now we take the same integers -1, -2, -6. Now we will add last two integers here. Now first integer is a -1, and last two digits integers are -2 and -6. Sum of these we will get a -8, and again we add a -1 and a -8 here, -9. Now from this statement 1 and 2, here we get the same answers. Now what we conclude here? Already we get the some idea. Now if we want to add three integers, we will add first two integers and third one, and first integer and add to sum of last two integers, we get the same answer. Now from this table here, a plus b plus c, for example a comma b comma c are integers. If we add a b c, add first two integers, after then third one also add, get same answer, adding last two integers to first one integer. Now by observation, integers are satisfied associative property under addition. In general, for any three integers a, b, c, a plus b plus c is equals to a plus b plus c. It means first two integers added, and this sum add to third integer, we get the same answer by adding last two integers and first integer. This property known as associative property under addition. Next one, closure property under subtraction. Now here statement and conclusion. 6 minus 3, 6 is a one integer, 3 is a one integer. So the operation between them is a minus, it means subtraction. So what we get here? 3 is also an integer. Now the difference is an integer. Next, minus 10 and minus 2. Minus 10, minus 2. Minus 10 also integer, minus 2 also integer. So here we get a minus 12. Here minus 10 is one of the integer, and a plus 2 is one of the integer, but operation is a minus, so we get only minus 12. So difference also an integer. Minus 3 minus 0, we will get minus 3. The difference also be an integer. Minus 5 minus 6, we get a minus 11. So the difference of these two integers, we will get an integer. Now minus 2 minus of minus 3, what we get here? Now observe. So minus 2 minus of minus 3, becomes plus. That's why minus 2 plus 3, we will get a plus 1. So here the difference of minus 2 and minus 3 is plus 1. Plus 1. So now the difference is an integer. Minus 4 minus of minus 4, what we get here? Minus 4 is minus of minus, we will get a plus 4. This sum is a 0. 0 also an integer. So the difference is an integer. Next, one more example. 7 minus of minus 6. So the difference between 7 and minus 6, we will get here 7 and minus of minus is a plus. So 7 plus 6, we get 13. So 13 also an integer. The difference is an integer. Now by observation from this table, difference of any two integers always an integer. So integers are satisfied closure property under subtraction. Now in general, for any two integers a and b, a minus b also an integer. This property known as a closure property under subtraction. Now commutative property under subtraction, it is satisfied or not, we will check them here. Now here statement 1 and statement 2 and conclusion. Here same. Now 5 minus of minus 6. 5 minus of minus 6. What we get here? It's a 5 plus 6. Minus of minus is a plus. So plus 6 we get a 11. And in statement 2, minus 6 minus 5. Here minus 6 subtracted from plus 5. Here plus 5 subtracted from minus 6. What we get here? Now here minus 11. In statement 1, we will get a plus 11. In statement 2, minus 11. These are not equals. So that's why we conclude that 5 minus of minus 6 is not equal minus 6 minus 5. Next, second example, minus 9 minus 8. We will get a minus 17. 8 minus minus 9. We will get a plus 17. In statement 1 and 2, we could not get the same answer here. That's why the difference is not equals. So now here minus 9 minus 8 is not equal 8 minus minus 8. Now minus 4 minus of minus 5, we get a minus 4, here minus of minus plus 5. Now here what we get here? Plus 1. Now the plus 1 is our answer for this first statement. In statement 2, here minus 5 minus of minus 4. we get same answer or not, just we check. Minus 5 minus of minus 4 is a plus 4, and we get a minus 1. In statement 1 and statement 2, we observe here it's a plus 1, it's a minus 1. So both are not equals. Now by conclusion, here minus 4 minus of minus 5 is not equal to minus 5 minus of minus 4. 3 minus 4, we will get a minus 1, and 4 minus 3, we will get a plus 1. In this case, easily we understood here, it's a minus 1, it's a plus 1. Both are not equals. So now here 3 minus 4 is not equal to 4 minus 3. From this table, by observation, integers are not satisfied commutative property under subtraction. In general, for any two integers a and b, a minus b is not equal to b minus a. This property known as a commutative property under subtraction. Now here associative property under subtraction. Now we will observe, take more examples, statement 1, statement 2 and conclusion. In statement 1, in associative property, we will take three integers. First we subtract first two integers, and after that third integer subtracted from that one. Now here subtract first two integers. 2 minus 3, what will we get here? Minus 1. And the next third integer is a minus 1. We will get a minus 5. In statement 2, here last two integers are subtracted, and after then that result are subtracted from first integer. Now we will check here. Now subtract last two integers here. Now 2 minus 3 minus 4. 3 minus 4 is, we will get a minus 1. So 2 minus of minus 1. We will get a minus of minus 1 is a plus 1, and 2 plus 1 is a plus 3. Now here we observe here in statement 1, here minus 5, and here in statement 2 plus 3. Both are not equals. Here now we will conclude that 2 minus 3 minus 4 is not equal to 2 minus of 3 minus 4. And one more example, minus 3 minus 6 minus of minus 5. We will do first two integers. Now here minus 3 minus 6, we will get a minus 9. So minus of minus, we will get a plus 5. So now here minus 5 plus 5. So minus 9 plus 5 is minus 4. And in second statement here, what will we get here? Now minus 3 and minus of plus 6 minus of minus 5 is a plus 5. So that's why minus 3 minus 11, we will get a plus 14. Now from these two statements, we conclude that here minus 3 minus 6 minus of minus 5 is not equal to minus 3 minus of 6 minus 5. Next, in third example, minus 1 minus of minus 2 minus 1 minus of minus 2 minus of minus 6. First we will do first two integers. So here Now, so in first case, minus 1, it's a minus of minus 2 is a plus 2. And next, minus of minus 6. Next here is a 1 and minus of minus 6 is a plus 6. So we will get here plus 7. And in statement 2, first we do last two integers here. Now minus 1 of minus 2 minus of minus 6 and minus 1 first integer. And what is the result of last two integers? It's a minus 2 and plus 6. Minus 2 and plus 6. Here, next minus 1 and minus 1 minus 4, we will get minus 5. Now here in statement 1 we get here 7, and in statement 2 we get minus 5. These are not equals. So here minus 1 minus of minus 2 minus of minus 6 is not equal to minus 1 minus of minus 2 minus of minus 6. From this table we observe if a comma b comma c are integers, a minus b minus c, if we do like this, a minus b first do and minus c, and in second condition, so a minus b minus c, if we do b and c subtracted, and now the result of b minus c subtract from ac, we could not get same results by statement 1 and statement 2. By observation, integers are not satisfied associative property under subtraction. Here in general any three integers a comma b and c, a minus b minus c is not equal to a minus of b minus c. This is known as associative property under subtraction. Next, closure property under multiplication. Now statement and conclusion. Here 6 and 3 are integers. Now product of these two integers we will get 18. Now the product of these two integers also we get an integer. Minus 2, 12 and 2. So the product of these two integers we will get minus 24. So minus 12 is an integer, 2 an integer, and the product is minus 24 also integer. So the product also an integer. Next, 0 and 5. These two are integers. Product of these two, 5 into 0, we will get a 0. 0 also an integer. So the product is an integer. Now minus 6 and minus 5. These are two negative integers. Product of these two negative integers, we will get a plus 30. Plus 30 is one of the integer. The product of these two integers, we will get an integer. So the product is an integer. Now 2 and minus 3. Product of these two, we will get minus 6. Minus 6 also an integer. So here we conclude that the product is an also integer. Minus 4 and minus 4. We take the same integers, but we will do multiply. Here 4 into 4 is 16, and minus of minus plus, we will get a positive integer. So the product is also an integer. Now 17 into 1, get a 17, the product also an integer. By observation, product of any two integers always an integer. Here, the integers are satisfied closure property under multiplication. In general, for any two integers a and b, a into b also an integer. This property known as a closure property under multiplication. Commutative property under multiplication. Here, now statement 1, statement 2, conclusion. 5 into minus 6, we get a minus 30. In statement 2, minus 6 into 5. Minus 6 into 5, we will get a minus 30. So in statement 1, in statement 2, we get the same answers. So that's why 5 into minus 6 is equals to minus 6 into plus 5. Next, minus 9 into 8, we will get a minus 17. 2. 8 into minus 9, we will get a minus 17. So both are same answers. So that's why minus 9 into 8 is equals to 8 into minus 9. Minus 4 into minus 5 is equals to plus 20. And minus 5 into minus 4, we will get same answer 20. So that's why minus 4 into minus 5 is equals to minus 5 into minus 4. Next example, 3 into 0, we get a 0. And 0 into 3, we will get a 0. In statement 1, in statement 2, we get the same answers. That's why 3 into 0 is equals to 0 into 3. So from this table, we observe here, by observation, integers are satisfied commutative property under multiplication. Now, in general, for any two integers a and b, a into b is equals to b into a. Associative property under multiplication. Now, in this property, we will take three integers. In statement 1, in statement 2, conclusion here. Now, in statement 1, first in associative property under addition, subtraction, we will take three integers. In this, here also we take three integers. We will do first, we multiply two integers, first two integers, and after then third integer multiplied. Now 2 into 3, we will get a 6, 6 into 4, and we will get a 24. Next, we could not multiply three integers at the same time. So in statement 2, we will do first multiply the 3 and 4, second two integers. Second and third integers we multiplied. It means last two integers. Now first integer is a 2, and product of last two integers is 12. So now again multiply 2 and 12, we will get 24. Now from this case 1 and 2, and it means in statement 1 and 2, we will get the same answers. So now here 2 into 3 into 4 is equals to 2 into 3 into 4. Next, one more example. Here we will take here three integers, minus 3 plus 6 minus 5. First we will do first two integers. We multiplied first two integers. Now the product of first two integers is minus 18, and third integer is a minus 5. And now again multiplied minus 18 into minus 5, we get a plus 90. And in statement 2, we do the multiplied last two integers, it means the second one and third one. Now here first integer is 3 and multiplication of last two integers is minus 30, and again multiplied 3 into minus 3 into minus 30, we will get a 90. So in this case, so in statement 1 and statement 2 we get the same answers. Next, minus 1 into minus 2 into minus 6, we multiply first two integers. The product of first two integers is what is the answer? First two integers product is plus 1 plus 1 plus 2. 1 into 2, 2, and minus of minus plus. And next is third integer minus 6. Next, so 2 6 are 12. So plus into minus, minus, minus 12. And the statement 2. Now we multiplied last two integer. Now here minus 1 into minus 2 into minus 6 is a plus 12. So finally we get a minus 12. So statement 1, statement 2 we observe here. So these are equals. Now minus 1, the product of minus 1 and minus 2 multiplied by minus 6, we will get the same answer. The product of minus 2 and minus 6 multiplied by minus 1. From this table by observation, now if we will multiply the three integers, we will multiply first two integers and multiply by third integer, we will get the same answer by multiplying last two integers and first integer. So here by observation, integers are satisfied associative property under multiplication. In general, for any three integers a, b, c, a into b into c is equals to a into b into c. Now closure property under division. Now statement 1 and conclusion. Here 6 divided by 3, we will get a 2. It is the quotient 2 is an integer. 6 is an integer, 3 is an integer. Quotient is also integer. Quotient is an integer. Now here minus 10 divided by 2, we will get a minus 5. It is also integer. So quotient is also an integer. But here 5 divided by 0. 5 is an integer, 0 an integer. 5 divided by 0, it's not defined. It's not defined, not 0. Observe, clean observe. Minus 5 is an integer. Minus 6 an integer. At division of these two numbers, we will get a minus 5 by minus 6. It also 5 by 6. But 5 by 6 is not an integer. It is a rational number. So here quotient is not an integer. Next, 2 divided by minus 3. So we will get a 2 by minus 3. 2 by minus 3 is not an integer. So the quotient is not an integer. Next, minus 4 divided by minus 4, we will get a 1. So it is an integer. Now here observe, here is a integer, here is a integer, here is a integer. In 3 examples we get a integers. But from another 3 integers we could not get integers. That's why from this table by observation, division of any two integers always may not be an integer. So in general, so the integers are not satisfied closure property under division. So in general, for any two integers a and b, a divided by b always not an integer. Now commutative property under division. Now statement 1, statement 2, conclusion. Now 5 divided by minus 6, we get a 5 by minus 6. And minus 6 divided by plus 5, we get a minus 6 by 5. So these are not equals. So some students are confused here. So 5 by minus 6, here minus 6 by 5. These are negative, but is a 5 by minus 6 is a 5 minus 6 by 5. Both are not equals. It's a numerator is a 5. Here numerator is a minus 6. Here is a denominator is a minus 6. Here denominator is a plus 5. So that's why these are not equals. So 5 divided by minus 6 is not equals to minus 6 divided by plus 5. In second example, minus 9 divided by plus 9. Here we get a minus 9, minus 1, sorry, minus 1. Plus 5 divided by minus 9. We get the same answer, minus 1. Here both are equals. Here equal. But in another example, we will see here minus 15 divided by minus 5. We will get a 3. And minus 5 divided by minus 15. We will get a 1 by 3. Here in statement 1, we have 3. In statement 2, 1 by 3. Both are not equals. So here, now minus 15 divided by minus 5 is not equals to minus 5 divided by minus 15. Next, 3 divided by 0 is not defined. And 0 by 3, we will get 0. Here in statement 1 not defined. In statement 2, we will get 0. Both are not equals. That's why 3 divided by 0 is not equal 0 divided by 3. From this table, here sometimes equals, sometimes not equals. So that's why it's not satisfied. By observation, integers are not satisfied commutative property under division. In general, for any two integers a and b, a divided by b is not equals to b divided by a. Associative property under division. Now here statement 1, statement 2, conclusion. Here we will take 3 integers. So between them the operation is a division. Why? Because we will check associative property under division. So first we do first 2 integers and we will go to third integer. Next, first we do 2 by 3. It means 2 divided by 3 is 2 by 3. And second is we write the reciprocal of 4 in division. So 2 by 3 into 1 by 4. We will get 2 by 12. In statement 2, we will take same integers 2 divided by 3, 3 divided by 4 here. And here in statement 2, we will divide the 3 and 4. It means 3 divided by 4. We will we apply the division process for last 2 integers. Here 2 divided by of 3 divided by 4. Here 2 divide by 3 by 4. We will get 8 by 3. In statement 1, we will get 2 by 12. In statement 2, 8 by 3. These are not equals. So here in statement 1, 2 divided by 3 divided by 4 is not equals 2 divided by of 3 divided by 4. Second example, take another three integers, minus 3 divided by plus 6 divided by minus 5. We will divide first two integers. We will get minus 3 by 6 and divided by minus 5. It means it convert into multiplication. It means into reciprocal of minus 5 is 1 by minus 5. We will get minus 3 by minus 30. In statement 2, same, we will take the same three integers. We divide the 6 and minus 5, means lost two integers here. Minus 3 divided by 6 by minus 5. Here's minus 3 into minus 5 by 6. This minus 5 by 6 means divided by here. That's why here we will write into reciprocal of 6 by minus 5. Reciprocal of 6 by minus 5 is minus 5 by 6. So finally we will get here minus 3 into minus 5 is a plus 15 and by 6. In statement 1, statement 2, we could not get same answers. So that's why statement 1 and statement 2 are not equals. And next, in third example, we will take another three integers, minus 1 divided by minus 2 divided by minus 6. We will do first two integers, and first two integers division is minus 1 by minus 2, and divided by minus 6 is in the process of division minus and divided by minus 6, it will become some multiplied as 2 3 minus 1 into minus 1 by divided minus 2 into, and reciprocal of minus 6 is 1 by minus 6. So we will get minus 1 by minus 12. And next, in this case, in statement 2, first we will do the last two integers. It means second and third one. So here minus 1 divided by, and division of first and last two integers, we will get minus 2 by minus 6. And next, minus 1 into the reciprocal of minus 2 divided by minus 6 is 6 by 2. So minus minus cancel here. Yes, minus minus cancel. That's why I will write 6 by 2. It is a reciprocal of 2 by 6. That's why I write here minus 1 into 6 by 2. Next, finally we get minus 6 by 2. So these are not equals. So here A divided by B divided by C. So if we do first two integers, and after the second, it's not equal to, and last two integers and first one. So these are not equals. So my observations from this table, integers are not satisfied associative property under division. So in general, for any three integers a, comma b and c, a divided by b divided by c is not equals to a divided by b divided by c. So from this table, associative property under division are not satisfied. So here, next we'll go to next, additive identity. We know the integers positive, negative and 0, and 4 is an integer and 0 is an integer. So we will get 4. The sum of 4 and 0 we will get as 4, and 0 plus 4, what is the answer? 4. And 6 plus 0, 6. 0 plus 6 is also 6. Now here another example, minus 3 plus 0, minus 3. 0 plus minus 3, minus 3. If we add the 0 to any integer, we will get the same integer. This property known as additive identity. Here 0 is called additive identity. 0 is called additive identity. 0, it's a 0, it's 0, it's 0, it's 0, 0. If we add the 0 to any integer, we will get the same integer. That's why this property known as additive identity. In general, any integer a plus 0 is equals to 0 plus a is equals to a. It means if we add the 0 to any integer, we get the same integer. So 0 is called additive identity. Now next, here 0 is the additive identity for the integers. Question: which is the additive identity to itself? Which is the additive identity to itself? What is the answer? Can you guess? Here 0. Reason is 0 plus 0, it's a 0. 0 is a integer. So again we add the 0, we'll get the same integer. So that's why 0 is a additive identity to itself. Next, 4 plus minus 4, we will get a 0. Minus 2 plus 2, we get same 0. 6 plus minus 6, 0. If the sum of any two integers is 0, then they are additive inverses to each other. In general, for any integer a, there exists an integer minus a such that a plus minus a is equals to 0. A and minus a are additive inverses of each other. Next, write the additive inverse of 7. Answer: let the additive inverse of 7 is equals to x. Now, the sum of any two integers is 0. So that are additive inverse to each other. That's why I will take the additive inverse of 7 is x. Now 7 plus x is equals to 0. So now here x is equals to minus 7. So minus 7 is the additive inverse of plus 7. Next, 8 plus minus 8 is equals to 0. So additive inverse of plus 8 is a minus 8, and additive inverse of minus 8 is a plus 8. Next, which is the additive inverse to itself? 0. 0 plus 0 is a 0. Next, multiplicative identity. Here 4 into 1 will get 4, and minus 6 into 1 minus 6, 10 into 1 10, and 1 into 5 so 5, and 1 into minus 3 same, we get a minus 3. Now we find that multiplying an integer by 1 does not change the integer. Thus 1 is called multiplicative identity for integers. In general, any integer a into 1 is equals to 1 into a is equals to a. So 1 is a multiplicative identity. So now question, which is the multiplicative identity to itself? Can you guess? Answer is a 1. Reason, 1 into 1 we get the same 1. So 1 is called multiplicative identity. So multiplication by 0. here 5 into 0 is equals to 0, minus 6 into 0 is equals to 0, 0 into 1 is equals to 0. Here we find that the product of any integer and 0 always 0, always 0. Now in general, for any integer a into 0 we will get 0, and 0 into a also we get the same 0. Find the products of the followings. Now 16 into 0, what is the answer? 16 or 0? Not 16, 0. And 0 into 8, what is the answer? Minus 70, and 0 into minus 99. So in first answer is 0, second answer is 0, third answer is 0, fourth answer also 0. 0 into something and something to 0 also 0. Division by 0. Now here it is a square. Now divide it into two parts. Yes, is it possible? Yes, two parts. And it is square. Divide it into three parts. Is it possible? Yes, we will do. We divide equal three parts. And another example, just square. Divide it into four equal parts. Can you divide? Yes, but I will do like this only. You also do another way, but here I will do here like this. Divide into four equal parts. Now in first example we will do divide into two parts. In second examples we will do equal divide into three parts. In third example we will do divide into four equal parts. Now this square, divide it into 0 parts. What does that mean? 0 parts. Divide into it into 0 parts. Is it possible? How to do? It is meaningless. We can divide anything into 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, and so on and so on. But not 0 parts. Any integer divided by 0 is meaningless. It is a meaningless. So now in general for any integer a divided by 0 is not defined. It is means it's meaningless. That's why it's not defined. And 0 divided by a is equals to 0 for a not equal to 0. Now any integer by 0 is not defined. It's very, very important. Next, 0 divided by any integer. Now 0 divided by 4. 0 divided by 4. 4 0 0. The quotient is 0. Next, 0 divided by 6. 0 divided by 6. Now the quotient is 0. 0 into 6 into 0, 6 0 0. So that's why we get the quotient 0. We take 8. So 8 0 divided by 8. 0 divided by 8. Here is next. The quotient is 0. Now in general for any integer a 0 divided by a is equals to 0 for a not equal 0. If a not equal 0, 0 divided by a, always we get a 0. It means 0 divided by any integer, it is a positive or negative, we will get the same answer is a 0. It means 0 divided by any integer, we will get a 0. Distributive property of multiplication over addition. Now here, statement 1, statement 2, conclusion. Now here, 9 of 10 plus 2. It means 9 multiplied by 10 plus 2. Now first we do the within bracket here, 9 into, so sum of 10 and 2 is 12. So 9 into 12, we will get a 198. In statement 2, 9 into 10 plus 9 into 2. Here we observe in second statement, 9 is multiplied by 10 and 9 multiplied by 2. So what is the answer in second statement? So 9 into 10 is a 90 and 9 into 2 is a 18. So sum of these two is we get a 198. In statement 1 and statement 2, we get the same answer. It means 9 of 10 plus 2 is equals to, we can write and we can do like this, 9 into 10 plus 9 into 2. Now second example, 5 into 10 plus minus 2. Now we will do the first within bracket here, 5 into, so 10 plus minus 2, we will get a 8. So 5 into 8 is a 40. In second statement, 5 into 10. Here is a plus. That's why I write the plus here. 5 into minus 2. Now 5 into 10 is a 50 plus 5 into minus 2, we will get a minus 10. Therefore, the answer is 40. In statement 1, in statement 2, we will get a same answers. Now conclusion is 5 of 10 plus minus 2 is equals to, we can do like this, 5 into 10 plus 5 into minus 2. So now by observations from this table, integers are satisfied. Distributive property under addition. In general, for any three integers a, b, c, a into b plus c, it means a of b plus c is equals to a into b plus a into c. A into b, here is a plus, so that's why a into b plus a into c. This is known as distributive property over addition. Distributive property of multiplication over addition. Next, distributive property of multiplication over subtraction. So now here, statement 1, statement 2, conclusion here. Now 7 of 10 minus 4. Here first we will do within bracket, 10 minus 4 is 6. So that's why 7 into 6. Now we will get 42. In statement 2, 7 into 10 minus 7 into 4. Now first product is a 70 and minus second product is a 28. Now we will get a 42. In statement 1, in statement 2 we get the same answer here. Now 7 of 10 minus 4 is equals to 7 into 10 minus 7 into 4. Now second example, 5 of 2 minus of 3. First we will do here within brackets. Now 5 into in the within bracket is a 2 minus of minuses plus 2 plus 3. We will get 5 into 5. We got 25. And same in statement 1 says 2, 5 into so plus 2 minus 5 into minus 3. Now 2 into 5 into 2 is 10. So minus of minus 15 years plus 15. That's why 10 plus 15 we will get a 25. Here from statement 1 and statement 2 we got a same answers. So that's why 5 of 2 minus of minus 3 is equals to 5 into 2 minus 5 into minus 3. Now by observation, integers are satisfied distributive property under subtraction. In general, for any three integers a, b and c, a of b minus c is equals to a into b minus a into c. We will write like this. So distributive property of multiplication over subtraction is satisfied for integers. Thank you for watching.